FutureMakers.
Let's make monster claws. With this FutureMakers Spark, your learners will build machines that move using push and pull forces on connected systems of levers, pivots, and pneumatic components. They'll successfully follow a specific plan to build and enhance their project to make it perform a unique task. This process-specific design and build challenge helps them understand visual sequences of information to accurately combine components, explain how forces are transferred, and confidently engage in troubleshooting and critical thinking. Here's what each learner receives to make monster claws. A laser-cut cardboard component sheet, a sheet of foam die-cut shapes, a pair of pistons and cylinders, a tube, a set of special fasteners, a visual guide, and a reusable, reclosable bag. Your learners will also need paper, scrap cardboard, scissors, tape, and art supplies to create enhanced components for their claws. To start, we'll assemble the system of cardboard parts that move. You'll need your laser-cut board and your fasteners. Remove all of the laser-cut cardboard components. They have unique outlines to help tell them apart. We'll call these levers. They have a row of small cutouts made for connecting fasteners. There's triangles, circles, and squares. These cutouts are designed to help match where parts connect together. Triangles always connect to triangles, circles match circles, and so on. Follow the layout in the printed guide, and you'll never connect different shapes. We'll build the longest part of the claw first. Find a bumpy bent lever and locate the two triangular cutouts. Remove two fasteners from the set. Press the fasteners all the way into each of the cutouts. They should stick out the back. Locate the triangles on a lever with straight sides and firmly press the attached fasteners through to connect the two parts together. For the next step, we'll only use one fastener. Find this square cutout. It's next to the end of the lever. Overlap both squares on another straight-sided lever and fasten them. With only one fastener, the two pieces will pivot. We'll fix this later in the build. To finish off the longest part of the claw mechanism, we'll use fasteners on the triangle cutouts. Take your final straight-sided lever and connect the triangles. You've created a long multi-component lever. Look to see that yours is assembled like this one. Time to make the other jaw of our claw. The two remaining levers are connected in a specific order. Fasteners first go in the triangles on the straight, bumpy lever. Then attach it to the last bent lever. This last move is critical. You'll need to find two specific circular connection points. One is furthest away from the bent end of your short lever assembly. The other is just above the pivoting fastener on the long lever. A fastener goes in this specific circle. Make your final connection to the circle above the point that pivots. You've created the basic mechanism of your claw. The two levers can pivot to make the bent jaws open and close. The long lever still has this part that bends in the middle. We'll fix that in our next steps. The system that makes your claw move has three components: a pair of pistons and cylinders, a tube, and a small sheet of foam holder parts that attach pistons and cylinders to the levers. These components have two connected parts. The piston slides in the cylinder. The cylinder fills and empties when the piston moves. Take the three large and one small foam holders out of the sheet. They're used in pairs. Our first cylinder and piston will use two large ones. Insert a fastener into a cut in the center of the holder. Bend the rings together so the fastener faces out. Gently press the cylinder into one, taking care not to roll or tear the foam. Continue through the other. Slide it to the top. Repeat this with the other large holder. Go slow to avoid damaging the foam. For the other component, extend the piston. Attach the large foam holder to the cylinder. The small holder will fit over the handle of the piston. Leave the piston pulled out. You'll have a few fasteners left over. Don't throw these away. You can use them later. The last moves are tricky, so be deliberate and take your time. Take a look at where we're going and refer to your printed instructions as well. The fasteners on each piston and cylinder have corresponding places left to connect. We'll be adding our tube last and tuning our system so it grabs perfectly. We'll attach the piston and cylinder that will be pulling and pushing to the end of the long lever. Find 2 cutouts and press the cylinder firmly. This will drive the fasteners through the board, securing it. Our final part will connect everything together. Remember that pivoting piece? Locate the cutouts below the pivot. Press the cylinder fastener through the top lever, then align and connect it to the one below it to lock it all in place. The last move is all about the piston. The fastener connects to the cutout at the end of the lever. Angle the lever to open the claw and press to connect. Time to connect the tube so our system can move. Push and twist the tube onto the end of the handle cylinder. When it's firmly attached, snake the tube around and over to the end of the other cylinder. Attach it firmly. The claw opens and closes because air moves between the cylinders when one piston is pulled or pushed. This makes it a pneumatic system. Pulling air out of the claw cylinder pulls it closed. Pushing air back in opens it up. If the cylinders aren't balanced, the claw won't fully open or close. You can balance the system by disconnecting the tube, pushing the piston all the way into one cylinder, and pulling the other piston all the way out. When you reconnect the tube, you'll have a better result. The claw might also move slowly or have limited motion if the fasteners and levers are connected incorrectly. If you need to remove a fastener, press the point against the table and gently push your fingers down on the cardboard on either side of it. You'll be able to remove the fastener without damaging the levers. If a component is damaged or the holes wear out, you can create replacement parts from scrap cardboard. Trace a rough outline and poke through the holes to mark them. Cut the shape out and use this piece as a replacement. Because this project is focused on following instructions to build a working example, there's a few things you can encourage learners to do once they've completed their core build to make this more creative. This will involve them testing and improving their design to change its function, appearance, or both. The first is to complete a relay race. Teams of learners can pick up and carry a set of increasingly more challenging objects and pass them to each other. The team that succeeds in transporting all their objects across the finish line first, without a claw breaking down, wins. Learners may find that the basic form of the claw isn't ideal for all objects. By using scrap materials and craft supplies, they can improve their claws to grip objects differently, make them stronger, or look more unique. If learners want a stronger push or pull, they can carefully experiment with hydraulics. Carefully add a small amount of fluid to the maximum fill line in only one cylinder. With a denser material to push and pull against, forces are transferred with more strength. Careful though, cardboard and liquid don't mix. Congratulations on creating monster claws. Every spark your learners make is unique and theirs to keep. They'll remember the projects they make with you for years to come.
Thanks for watching.
FutureMakers.